Workshop. I'm back here over at the K&T, and I'm anxious to get the finished milling done on the radial arm saw casting, the one that I broke. So we were almost done fitting the rotational spigot piece in place. I got a few more passes to make with the boring head, thousandths at a time. A little bit of cleanup, then we can start assembling this thing. So let's get right to it. Going another thousandths and a half. That's cast iron. That is not the weld. This is the first time it sounds like we're touching something almost all the way down. Now we're into that relief area in the middle of the casting. Hopefully last pass. That will go all the way down, especially once I've released everything and that is tightened against the gauge block. You can see that I've got surface cleaned up on that side, maybe about 90 degrees. Same on the bottom. A little bit right at the split. And on that side and at the bottom again. So definitely this was not round. Nice pile of shavings in the bottom there. Well, I've got a nice slip fit of the rotating spigot there. I don't even know what you call that part. And before I move this arm, while I've still got my zero, there's two more operations I want to do. And the first one is to just take a very, very light cut on this top surface. Since we had some distortion in the welding, I want to make sure that this top surface is perfectly perpendicular to the bore that we established, and that is a perfect job for the rotary head. So let me show you what I'm trying to clean up. I don't really feel any raised areas anywhere, but there is just a tiny bit of weld spatter here. And obviously it doesn't project into the bore because we bored through this, but just going to make a real light pass across the top. There's a radius in here, but a 3/4 inch wide cutter is wide enough to span this entire distance, come into the bore and come up almost against this edge here. Interesting, this scallop is on a bigger diameter than this circle. So in other words, it's not concentric. I guess you can see that with the paint here, and it's much wider here. I was going to break this edge with a chamfer cutter, and I'm going to have to figure out what that radius is if I wanted to do that, and where the center would be. Yeah, so I was milling up to about here, and now I'm not. I'm going to let this do a full pass, and then I'm going to just bring it down another hair till everything cleans up. Only had to move another couple thousandths in order to get this to start cleaning up. And you can see here I'm only partially removing the paint. I'm just moving my table off axis about a little less than a quarter inch this way and 50 thousandths back. I've got this tracking within about 5 thousandths. So this radius was about a quarter inch, probably about a quarter inch bigger than what would have swung from the exact center. But now that, you know, the motion of the head basically follows that arc, I'm going to break this edge with a chamfering bit. Now, being that this casting raises up from, let's say, an 1/8 inch or 3/16 up to a quarter inch plus, the scallop that I cut is going to be a little bit deeper in the middle than at the lead in and the lead out, but it'll be a neat feature there. I'm going to increase the radius 5 thousandths. Let's just go back and forth. This isn't a deep enough cut to worry about climb milling it. That's starting to look pretty nice. I'm going to go another 10 thousandths on the radius and reevaluate if we're going to go any further. I did a tiny bit of hand work with a file on those edges there and all around the perimeter. And with that, I'm going to call the top surface done. And here's what I was left with after all the cleanup. Significant amount of rusty cast iron. Cardinal rule of working with this machine, whenever you start indicating, is you bring the head back to zero. And I know from experience, if you don't, and then you try to do a circular feature it will dart off into some weird direction and ruin your part. So my procedure has been to zero the head coming out, which is numbers climbing on this dial. Everything's flipped over and I'm back on zero. It's not critical that I'm perfectly centered because I'm not doing any boring operations. I'm just doing a light facing cut on this surface, primarily to get rid of that. So we'll offset the head and go after this hard weld. Hopefully my clamps will hold. Being that this is the surface I started with, I'm assuming this is going to be pretty parallel to the one I just finished, but you never know with the weld distortion. Might be some spatter up here on the nose to get rid of. Okay, I'm going to come down just a hair. And it appears I can come down a bit more. Finish pass of 1/1000 depth of cut. I'm going to just move the table and mill these little wings off here. Once again, that's something that you can see, but you can't feel, so it's no more than a couple tenths. So we'll do a little, just a handwork on those edges to break the sharpness and dismount everything. Nothing about this saw is light, so I made a bridge out of some plywood and boxes here to support this arm until it's in place. There's two locating dowels to keep it positioned. One little correction I had to make to this piece before I slipped it in for the final time was this center stop, the 90-degree stop. The 245s you can see are oriented vertically, but this one was skewed fairly significantly, so it was a bear to get out. It has a tapered hole, a short retaining screw, and then washers on the back side. Looks like that inside. So I'm going to try to figure out a way to align this, maybe just vertically with the floor, and get it back in before I drop this guy into place. Looks pretty good. See if I can improve that a bit. Okay, everything's cleaned up. I've got my nice new scallop in place here. I've got my 3 indexing bushings vertically aligned. Did some quickie repair on the scale. So let's just seat this guy. Now I have to come up with a way to hold the arm up. That's this beast. Hold it up against the underside to get some 1/2-13 socket head cap screws in place. It's usually thought that radial arm saws aren't as accurate as table saws, but I think they can be if they're set up properly. It's just a little trickier. So we'll go through this thing as much as we can and make it as accurate as it ever could be. This connection is a static connection, so I just want it to be nice and clean. All it takes is one. You know, nice and stiff the way it should be. Got that fairly tight, and it's still moving. I'm going to have to get it to where it will not move. And for that, I need a slightly longer tightening lever. Oh my, I think we have a success. That's not too bad. That's, I don't know, maybe 20 foot-pounds on there. I can still move it, but it doesn't take much to lock it up. So I think we can proceed with fixing everything else on the saw. And that's going to be an interesting one, because here is the next item. This is the yoke, mounts the motor, and this clamp is broken, this wing right here. Instead of just welding on a chunk, I think I'm going to machine this off, make a new piece that will bolt in with inserts, and then clean up this bore. The challenge is going to be machining this thing, holding it, without it acting like a tuning fork. It is aluminum, but I'm going to need to support the underside of this somehow on like a riser table, and then that way I won't be, you know, reaching past this bottom edge. So got my challenges ahead of me on this, but at this point I'm going to call this a success. So thank you for watching, sticking with me on this project. It's been like 2 years since I started this thing, the $60 radial arm saw, but it'll be well worth it when I'm all done. So till next time, as always, stay safe.